Okay, so today we want to discuss inequalities. And inequalities are just ways to talk about numbers that are greater than, less than, greater than or equal to, less than or equal to give you a sense of there are a bunch of right answers, but we need to start at a specific location. So for the first symbol, this symbol right here is going to be less than. And when we read left to right, you would say x is less than 3. So yes, they open both directions, but there is a specific name for the direction that it opens. So now let's look at what number we're talking about. So the number specifically focused on is 3. Now, there are two types of 3s. It could be equal to 3, or it could get right up to it, but not equal 3. So, for this problem specifically, it's saying x is less than, strictly less than, 3. So we want to talk about all of the numbers that are less than 3. Well, what numbers are less than 3? 2, 1, 0, so on and so forth. That's why we draw the arrow this way, indicating that every number that is less than 3 is actually a right answer. Hey, thanks. Yeah, they're tucked away over there, sleeping away. So this is x less than 3. Now, we have less than or equal to. So now when we get our number, so when we pick that number, where's my pointer? -1. So we're going to draw a circle around -1. But you can see x is less than or equal to -1. So now this is where it could actually equal -1. Like we could get to 2.999999, but we could never touch 3 on this graph. Where this one, we could get negative, let's see, negative 2.000001 or negative and then we are going to go in this direction. So we could get really, really close. So what's that? 1.000001. We can get really close to -1, but we can't ever touch -1. But in this case, we can once we close that circle in. So if it's equal to, we can get right up to -1. Next one, -2. -2, we are looking strictly at greater than. So that means all of the numbers to the right of -2 are the ones we're going to highlight, just like we did for this one. So -1 is greater than -2. 0 is greater than -2. 2 is greater than negative. So you can see how all these answers are correct. Now, if I were to put -2 in there, is -2 greater than -2? And that's why that becomes false. We can't talk about that because it's not greater than, it's just equal to. So when we adjust that thought, here we go, here's our 0. We're going to color that in so that we can equal it to 0. And then all of our numbers that are greater than are going to be over here. All right, next one. So this is where we have to kind of pull back, and you will want to go to a prior video of solving for a variable. So we're going to draw a line down the middle of the equal sign, and we're going to underline our variable. So our variable is right there. So we need to get rid of the numbers that are on the same side as our variable, as our highlight. So how do we get rid of a -1? Well, we're going to add 1 to both sides of the function. So the -1 and the +1 are going to cancel each other out, and we are left with 3x. Now, this symbol doesn't change. Only when you multiply or divide by a negative does that symbol flip sides. So if it's greater than, it's going to stay greater than. And then 2 plus 1 is 3. Now, in between 3 and x is multiplication. So to get rid of multiply, we need to divide both sides by a 3. This will 1 those out, and we'll be left with x greater than 1. Well, here's our 1, and x being greater than is going to be on this side, all the numbers that are greater than. And then, do we color it in? No, because it's not equal to. Now, if we want to put some justification down, this is given. Then we have addition, property of equality. Then we have zeroing out the ones. That's how we get to this step. Then we're going to do division, property of equality. And then we are wanting out the 3's. And there's our justification. So I would have you try B and C, and I will go to D. So the first thing we want to do is get rid of this fraction that's out in front. And you might go, it's a fraction. It's okay. 4/3 times 6 over 1. That's how we're going to set it up. And when we're going to do 4/3 times 9 over 1. Now, the beauty of it is 6 can be divided by 3. So when we look at this, 4 over 3 times 2 times 3 over 1. Because what's 2 times 3? Isn't that 6? And now, do you see the 3 on the top, 3 on the bottom? Those will 1 out. 4 times 2 is 8. And that leaves us with 8x. Same thing here. We're going to have 4 over 3 times 3 times 3 over 1. Got a 3 over here, 3 over there. Those are going to 1 out, 1 on the top, 1 on the bottom. And then we're just going to do 4 times 3, which is 12. So that's going to be plus 12, greater than or equal to 4. Okay. Now we can underline, draw our line, finish solving that. And hopefully you get to be x is greater than or equal to some negative. Is that going to be negative 1? Because that's going to be negative 8 divided by, so this, and then point in that direction. So this is given distributive property. Then you're going to have to go through these steps. You're going to do the subtraction property of equality to 0 out the 12s, and then division property of equality to 1 out the 8s. So this process just keeps repeating itself over and over and over again, not just in algebra, but in geometry and algebra 2. This is going to be one of those processes that you just continually to do time in and time out. All right. Now, what happens when we have a negative and we have to multiply or divide? We can add and subtract all day long. But when we multiply or divide by a negative number, that is when the inequality has to flip over. Now, this becomes x because these numbers just one each other out. And then 15 divided by 5 is going to be 3. A positive divided by a negative is a negative. So x is going to be greater than or equal to negative 3. And because we multiply or divide by a negative number, this inequality right here has to flip over because you multiply or divide by negative. Multiply or divide by a negative, flip the sign. Okay, so let's look at this one. Here's your variable. Draw a line down the middle of the equal sign. First thing we're going to do is subtract 11 from both sides. So this was given. Then we're doing the subtraction property of equality. This is going to give us negative 3x. is still greater than, and then this is going to be negative 9. But once, no, I need that, but I need to change this. But once I divide and I do, so this would be 0 out the 11s. I'm going to divide by negative 3, so that's the division property of equality. The negative 3s are going to 1 out, so that I'm left with x, and then I have to flip this sign, and then this becomes a 3. So x is less than 3. Okay. So now it's just about putting all these combinations together and really trying to get a solution. All right, so let me try the first one, and then you can do the second one. So the first thing I want to do is distribute this into the parentheses. So a negative 5 times 7 is a negative 35. First off, this is given. Then a negative 5 times a negative 2 is a positive 10, and then keep the x. And then x plus 1. So when we highlight, I have an x here, I've got an x there. Draw a line down the middle of the equal sign, and you can see that the highlights are on two different sides of the equal sign. So that means we need to move one of them to the other side. And it doesn't matter which one you do. You can choose no matter what. No, what? Come on now. I just fixed that. Okay. Great. So I'm going to subtract 1x. So this was distribution property. Then I'm going to do the subtraction property of equality because we're doing something to both sides. And the reason we're doing something to both sides is because what is 1x? Take away 1x. Isn't that 0? So these 0 out the 1x's. And then we still have negative 35 plus, now it's 10 take away 1 is 9x. Okay. Now we're here. Highlight again, and we still have that. But now we only have one of them. So that means we need to get rid of the two numbers that are on the same side. So I'm going to add 35 to both sides. Well, why would I do that? Well, here's the highlight. So I need to get rid of the minus 35 and then plus 9 next to the x. So in order to do that, we want to get rid of the 35 first because it's farthest away from x. When we read this, it says 9x. Okay, so that 9 is directly linked to the x. So we want to get rid of the number that's farthest away first. So when we do that, we're doing the addition property of equality. And then that's going to 0 out the 35s. So then I'm just left with 9x, and then this is 36. 1 plus 35 is 36. So 36 less than 9x. Then our last step, we want to get rid of the 9. So that's division property of equality. And I'm going to divide both sides by 9. 9 divided by 9, we're going to 1 out the 9s, and we're just going to be left with x. And then this is 4. So 4 less than x. So what does that look like? Well, we definitely have 0, 1, 2, 3, and 4. So here's our number 4. It's not colored in because it doesn't have a equal to sign underneath it. Well, 4 is less than x. So think about that. If 4 is less than x, then that means x has to be, hopefully you're starting to think about 4 is less than, well, and here, why don't we try it? Is 4 less than 3? No. Is 4 less than 2? No. Is 4 less than 100? Yes. So that means we have to point it in this direction. Okay. Oh, another one. Just multi-stage problems, just getting a little bit more complicated. We need to do the distribution property first, combine like terms, then move one to the other side. These are just practice, practice, practice. Now, let's try a story problem. Kara has $25 to buy dry pet food. Okay, so we have 25 food and treats. So it's food and treats. Something tells me we're going to have to break it up. A pound of dog food costs $2. So we said food was blue. And treats was red. $1. If she buys 9 pounds of food, what is the greatest number of treats she can buy? So Kara has 25. So we need our answer. Let's think about it this way. Our expression needs to be less than $25. Okay? So if it is $2 for food plus $1 for a treat, then that has to be less than 25. If she buys 9 pounds of food, so that's going to be 2 times 9. Oh, thank you, Hillary. Much appreciate that. It's going to be less than 25. So when I do 2 times 9, that's going to be 18 plus a t is less than 25. So there we need to subtract 18, because if we subtract 18 from both sides, these 18s cancel out, and t is going to be less than 7. So what is the greatest number of treats she can buy? Well, if she buys 7 treats, it will be exactly $25. So does she have $25? So maybe this should be less than or equal to, right? Because we could equal $25, we just can't go over $25. And they didn't say anything about tax, so, but you can play that game too. So I do believe 27 treats is the most we can buy with $25. Because we'll just break even, or we spent the same amount of money. All right, so that is our inequalities.